This second video of the MPLS WAN series uses the same customer network as the first one, showing sites in Seattle, LA, Chicago, Dallas, and New York. This video highlights one of the other aspects of trust placed in the MPLS VPN service provider. That is, the proper distribution of customer prefixes between all the connected VPN sites. What would happen if the provider mistakenly started announcing prefixes that weren't from a given customer's network? This could be fine if these prefixes weren't already in use, but what if the service provider limits the number of prefixes announced to the customer site? Not an uncommon design. This could lead to a situation where legitimate site-to-site routes are dropped because the prefix count exceeds the allotted amount. Random connection issues that are nearly impossible to troubleshoot could start appearing. Wouldn't it be great if you could actively be notified when unexpected prefixes have been injected into your network by your VPN provider? Here we have an email alert sent from the Route Explorer product when some unexpected prefixes were announced into the Seattle site from an MPLS VPN provider. This is the beginning of a workflow to verify that these and possibly other prefixes did not get sent inadvertently into the network. Since the alert does not list all the prefixes, I will connect to the Route Explorer product to determine whether they are legitimate for the network or not. I'll go ahead and log into the VNC UI of the Route Explorer appliance monitoring the live MPLS WAN network. Again, a quick scan of the connections shows that the network appears to be healthy, at least from the Layer 1 and Layer 2 plane of the OSI network protocols. I'll go ahead and set the date and time back to just after the alert was sent. The ability to know what prefixes are expected and in which sites they should originate from or be propagated to is controlled by defining this information in the Expected Prefixes table of the MPLS WAN Administration UI. This interface helps to define a baseline or steady state for all the prefixes being used in a customer's network. The Seattle site is expected to announce the prefix 10.66.0.38/32 representing router 38's loopback 0 address. In order for this loopback interface to be reachable from the New York network, we expect to see this prefix received by the routers in the New York site. We defined all this information as the sites were being added to the monitored network. Now the routing status report, which we'll open now, has a baseline state to help identify any reachability anomalies or the possible injection of unexpected routes. This report gives reachability indications between the different sites and also the VPN cloud. Reachability basically means prefixes are being announced in the appropriate sites to allow other sites to reach one another as well as the VPN. When a prefix is announced into the customer's network, it becomes active. If the prefix is an expected one based on the settings in the Expected Prefixes table, then it's defined as an active expected prefix. If it's not defined in the Expected Prefixes table, then it's categorized as an active unexpected prefix. And that is exactly the category identified in the Received Prefix Gain alert shown at the very beginning of this video. If I now look at the reachability by VPN for any of the sites, I notice there are 14 unexpected prefixes from 3 sites and 12 from 1 site. If I click on the Seattle site, I can show the prefixes that allow the VPN to reach the Seattle network. In this case, there are 14 prefixes that are active but not expected. These prefixes are not part of the current VPN network and appear to be related to a router which doesn't exist in the current network. Another key indicator that these are leaked routes is that even though these 14 prefixes are active, no site is identified as having announced the prefixes. Once the bogus prefixes are identified, then the history function can be used to see if the provider has identified the problem already and removed the leaked routes. To do this, I'll select the reachability to other sites and then right-click on the Seattle site and bring up the history of events for that site. VPN routes are being propagated using the BGP protocol, so I'll select the tab for only BGP events. I'll now click on the Event Analysis button and choose a half-hour window on the graph around when the alert was received at 12:30 a.m. I'll focus on the IPv4 prefixes that are present during the period of this analysis and bring up the specific events for the 10.66.3.81/32 prefix identified in the alert. The prefix details tell me that the PE router 10.65.50.115 was the originator of this prefix. At this point, we can hand off this issue to the VPN provider for further investigation on their end and provide them with a list of the leaked prefixes and, more importantly, the PE router that was leaking them. If I want, I can widen the time frame to see if the provider caught the mistake and has already removed the prefixes from the customer's network. Does this make sense? Can you see how the initial real-time alert that started this workflow can protect your network from either exceeding your allowed prefix limit or worse, receiving conflicting routes that already exist in your network?